In this video, we will learn how to explore image analysis results in PathViewer. To start, we're looking at just the nuclear channel of a multiplex fluorescence image, and this is overlaid with a label image which represents nuclear segmentation, in this case from Stardust. Now, the segmentation can come from anywhere, so it could have been generated from within OmeroPlus using our segmentation connector, or it could have come from a third-party application like VisioFarm, QPath, or Halo, all of which we have integrations with, or even your own custom analysis pipeline. In a previous video, we demonstrated how to change the visualization settings of this label image, changing its color and its transparency. But today I want to dynamically update the visualization of these objects based on some features or measurements that I have describing these objects. And for that, I use the Data tab. To start, I've created some groups of objects based on their size: big, small, and medium nuclei. When I turn these on, you'll see that my objects are color-coded based on their size, and there's 3 potential levels indicated by yellow, green, and magenta. You can see the magenta objects are particularly hard to see because they're so small. I'm able to do this because for each object in this label image, I have measured the area of the nucleus in square microns. And so in order to color an object green and call it a big nucleus, that area has to be greater than 100. I have a number of other measurements that I could include in this filter, and these measurements are completely custom to your workflow. Instead of distinctly or discretely grouping objects, I could also color the objects based on the continuous representation of their area, for example. So to do that, instead of picking a fill color, I indicate that the color should be based on the area of the nucleus. And so here, objects are color-coded based on a scale from low to high area. Finally, I can create a new label group which represents a more complex set of conditions. So to do that, I create a group here. I select a fill color or use the one that's automatically selected for me. And I could say here, for example, I want the area to fall within a particular range, so greater than 5, but less than 100. And I also want these objects to be particularly bright in the nuclear channel. And so I'll select that channel's mean intensity and say that that value should be greater than, let's say, 10,000. And then I'll hit apply. And you can see that a subset of my objects are colored in this teal color, and I can call these my ideal nuclei. And that's how you use the Data tab within PathViewer.